We're given the complex numbers z, which is 3 plus 5i, and w, which is 2 minus 3i, and we want to find the following things. Now the real part of z is just the real coefficient here, so that's going to be 3. The imaginary part of z is just the coefficient here, the I is not included, so that's 5. W bar, which is known as the conjugate of w, has the same real part as w, but the imaginary part changes in sign. So this is 2 minus 3i, so the conjugate is 2 plus 3i. And the same idea with the conjugate of z, z bar, that's going to be 3 take away 5i. So the imaginary part changes sign. Now sometimes you might see the notation star for the conjugate rather than the bar, so just be aware of that. Now, w times w bar. So that's going to be 2 minus 3i multiplied by 2 plus 3i. Note we've got the difference of two squares here. I'll do this one in full, and then when I come over here, I'll make use of the difference of two squares. So if we're expanding out here, then I'm going to use the smiley face pattern. So I'm going to get 2 times 2, so that's 4. Then I'm going to get minus 6i. Then I'm going to get plus 6i. And then I'm going to get minus 9i squared. The middle terms cancel. We'd expect that for a difference of two squares. So that's 4 take away 9. And don't forget I squared is negative 1. So that's going to be 4 take away negative 9, which is 4 plus 9, giving us 13. Now, z bar z is 3 minus 5i, 3 plus 5i. So making the use of the difference of two squares, we're going to get 3 times 3, which is 9, take away 5i all squared, so that's 9 take away negative 25. 5 times 5 is 25, and I times I is negative 1. So that's 9 plus 25, which is 34. Now note that w was 2 minus 3i. And if you do 2 squared plus 3 squared, you get 13. And over here, z is 3 plus 5i, and if you do 3 squared plus 5 squared, you get 34. Now, what is 2 squared plus 3 squared? Well, if you square root that, that's the modulus of w. And the same over here is that if you square root 3 squared plus 5 squared, that's the modulus of z. So it appears from here that w bar is the same as mod w squared, and over here z bar z is the modulus of z squared, and we'll be looking at that in the next example.